So children, now that we are aware what is distance formula, it is always the distance between 2 points, irrespective of the points lying in any quadrant. What was that formula, children? Distance formula was given by square root of the sum of the squares of the differences between your x coordinates and the y coordinates of those two endpoints making that segment. So it was x2 minus x1 the whole square plus y2 minus y1 the whole square. Now children, let's take a problem where we know we can find out distance by using the formula directly, or the second method that we have seen is by using Pythagoras Theorem. So first, Pythagoras Theorem, how will we use it? Is AC a hypotenuse of a right angle triangle? Can we construct and make it a hypotenuse of a right angle triangle so that we can apply the Pythagoras Theorem to find out the length of hypotenuse, that is length AC? Yes, definitely we can do it. We have already seen. For that, what do? Drop a perpendicular from the end point A towards your x-axis. So children, I drop a perpendicular. I mark it that it's a perpendicular. From point C, again, drop a perpendicular towards the first one named as AD. So let's drop a perpendicular to AD. This is AD. So again I have dropped a perpendicular. Let's name it as E. What are the coordinates of point E? Let's see. Coordinate X for point E will be 2 and coordinate Y will be the same as it has got for point C, that is 2. Now children, triangle AEC becomes a right angle triangle. So in the first case, we are not directly going to use the formula, but we will employ Pythagoras Theorem to calculate the distance AC. How do we use Pythagoras Theorem, children? By using Pythagoras Theorem. Will calculate distance AC. So let's start with it. What is Pythagoras Theorem? It states that AC square, that is hypotenuse square, is equal to the sum of the squares of the other two sides making up the right angle. So that is AE square plus EC square. So to calculate AC, first we will find out the length AE and then the length EC. So let's proceed. First, let's calculate length AE or distance AE. Now children, as we have already seen, look at AE. X coordinates of both the points are same, right? Because this line or this segment or side of this triangle is parallel to y-axis. So x coordinate is same, that is 2. So we have to take the difference of only the y coordinate, that is 3 and 2. So what is the difference? 3 minus 2, which is equal to 1 unit. This gives me distance AE. Let's calculate distance EC or CE. Again children, if we see CE, it is parallel towards your x-axis. So what happens in this case? Your y coordinate remains the same. So we just take the difference of your x coordinates. Larger coordinate minus the smaller x coordinate, that is 2 minus of the smaller coordinate, that is minus 2. So 2 minus into minus gives me plus, which is equal to 4 units. Now children, we know distance AE, we know distance EC, or you can say CE. Let's substitute and get the value of length AC. Therefore, AC square will be equal to AE square plus EC square by using what? By Pythagoras Theorem. So what is the distance AE? Let's substitute. Distance AE is 1. So 1 square plus what is the distance EC? 4. So 4 square. Let's not forget the square, children. So that will be giving 1 square is 1. 4 square is 16. Therefore, AC square is equal to 17. Let me continue on this side. Taking the square root on both the sides, as we want not AC square but only the length of AC. So, square root of AC square is equal to square root of 17. Therefore, AC is equal to 17 units. So, children, here we got the length of AC. But what did we apply? Did we use the formula directly? Definitely not. What did we use? We used Pythagoras Theorem to calculate the length AC. And how is AC? Is it parallelly placed to the x-axis? No. Is it parallel to y-axis? No. Are the points A and C on the x-axis? No. Are the points A and C on the y-axis? Definitely not. Then how is AC placed? It is placed in any position that is slanting and the end points, that is A and C, lie in any quadrants. So this is the way we calculate by the first method, by using Pythagoras length, that is AC, which gives me 17 units. Now children, we go into the second method where we use the distance formula directly. Let's not forget the answer that we got. AC we got as 17 units. Sorry, it is root 17 units. Okay. Now let's calculate by using the distance formula. Once again I repeat, distance AC that we got by using Pythagoras Theorem is root of 17. Now let's see if we get a difference in the answer if we use the second method, that is by using the distance formula. Now what is the distance formula? Let's write it down. We have to calculate the distance between AC. Therefore, distance AC will be equal to, let me first write down the formula. What is the formula, children? x2 minus x1 the whole square plus y2 minus y1 the whole square. Now, what is x1? What is x2? What is y1 and what is y2? What do I substitute? We will substitute them as the coordinates of the end points of the given segment whose distance has to be calculated. Which are the two end points, children, over here? A and C. So A has got coordinates 2, 3. C has been given the coordinates -2, 2. Let me put the first one as x1, y1. The other one as x2 and y2. Right. Let's substitute. So therefore, distance AC will be equal to square root of x2 minus x1. What is x2 minus 2? Let's just substitute. Minus 2 minus x1. What is x1? 2. The whole square. Next bracket contains the difference between the y coordinates. That is y2 minus y1. That is 3. The whole square. Let's solve it correctly without any errors. Square root as it is. What is inside the bracket? Let's first solve it. minus 2, minus 2. What do we do with them? We add them and put the common sign. So 2 plus 2 gives me 4 with the common sign, that is minus the whole square. Plus, let's look into the next bracket. 2 minus 3. 2 has got a plus sign, 3 has got a minus sign. What do we do when they have unlike signs? We definitely subtract greater number minus the smaller number, and the answer gets the sign of the greater number. So let's start. 3 minus 2 is 1. Who was greater? Was 2 greater or 3 greater? Definitely 3. What is the sign before it? Minus. So the answer gets a minus sign. Let's not forget the square. Okay. Let's continue to. Distance AC is equal to. Now, minus 4 square. What does it mean? Minus 4 into minus 4. Minus into minus gives me plus. And 4 4s are 16. Let's write it down. Plus minus 1 into minus 1. Again, minus into minus gives me plus. And 1 ones are 1. So, 1. Therefore, distance AC is equal to root of 16 plus 1 gives me 17 units. So, children, we have got the same answer. Whether you use Pythagoras Theorem or whether you use the distance formula, the answer remains the same. But what we have to be careful is never make an error in the mathematical steps concluding with the answer. So we have learnt over here how we use distance formula. So children, in the preceding sessions, what did we learn? We learned how to find out distance when the points are lying on the x-axis. Anywhere on the x-axis, take the difference between the coordinates. If the points are lying on the y-axis, again take the difference between the y-coordinates. If any line or segment is parallel to the x-axis, so what happens? Y-coordinate remains same. Again you take the difference of only x-coordinates. If that line is parallel to your y-axis, then x-coordinate remains same. Take the difference of the y-coordinates. That will give you the difference will give you the distance between the 2 points, the length of that particular segment. And the last, that is distance formula. What did we learn in it? If a line is anywhere placed in any quadrants, the 2 endpoints are lying. How do we do it? We proceed by either using the Pythagoras Theorem, by constructing a right angle triangle, or directly we can use distance formula. Now one thing children, over here, definitely you might be having a doubt. I have put the coordinates of A as x1, y1, coordinates of C as x2, y2. What happens if I write the coordinates of C as x1, y1 and the coordinates of A as x2, y2? Definitely children, when you properly substitute, you will get the same answer, because we are talking about the same side over here, AC. So whether you find the distance as AC or you find the distance as CA and put the coordinates as x1, y1 and x2, y2, or x1, y1 and x2, y2, definitely the answer will be the same.